This is Unit 7 Mastery Project for FRQ1, and Part A, it is asking us to draw and label the forces exerted on block B, and block B is on top of block A. So, since the spring was pushing block A to the right, I thought friction is opposite of motion, so I thought it would be pointing to the left, but that's wrong. So that's why I only got 1 out of 2, because I did label gravity correctly and thermal force on block B, but friction is pointing to the right because the reason why block B is moving is because of friction from block A, which is like, it should be like, friction should be pointing like that instead. For part A, though I got it wrong because I didn't know how to do it, but it is asking us to calculate a numerical value for the maximum oscillation amplitude A max that block spring system can have, such that block B will not slip on block A. So in order to do that, you need to find the amplitude, and since amplitude is proportional to the displacement in Hooke's law, so F equals kx. Instead, this will be k times a, and this is what we're trying to find. So instead is a equal to force times by k. In order to find force is equal to mass times acceleration. Force is equal to mass times acceleration, and the mass is ma plus mp because there's 2 of them and they're on top of each other. And the force is force of friction, but since force of friction is equal to mu times Fn, but Fn is based on the free body diagram. Fn is also equal to mg, so you replace that with mg. So that means mg is equal to, or mu mg is equal to mass times acceleration, and if you get rid of both masses, so the acceleration is equal to mu times g, and so A should equal to ma plus mp times, because force is equal to mass times acceleration, times the acceleration, which we derived is mu times g divided by k, and if you plug in the values, you should get 0.18, which that's the answer. So amplitude is equal to 0.18. Part B is asking us, is telling us that students are observing the 2 blocks are discussing energy. One student makes a following claim: because the kinetic energy is proportional to the mass, the maximum kinetic energy of block C is greater than the maximum energy of block A. Indicate whether student's claim is correct. Just right answer. So I said that is incorrect because the energy is actually, since for energy is MEI equals MEF, and the MEI is the potential spring energy, because there's a spring, and the MEF is the kinetic energy. So that means the energy from the kinetic energy should be proportional to the spring potential energy, and since the spring potential energy doesn't have mass in its formula because it's 1/2 times k times delta x squared, that means the mass won't mean that the kinetic energy will be higher. And that's what I said, and for that I got 3 out of 3 points because I indicated that was wrong, and I explained how it was equal to the spring potential energy, and I indicated that the maximum kinetic energy of each block is equal to the maximum potential energy of the string. So I said,